we want to be able to commit the sine, the cosine and the tan functions for these common angles: 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Now here's a quick and easy way to remember it, and we'll fill out this table as we work through this video. So if we start off with an equilateral triangle, so that's a triangle with all sides equal, and we'll say each of the sides are of length 2, so that's 2, 2 and 2. So that means if each of the sides are equal, then all of the three angles must be equal, and all of the angles add up to 180 degrees. Therefore this angle must be 60 degrees, that must be 60 degrees, and this angle in here must be 60 degrees. Now if we were to take the perpendicular from this point here down to this line, then it's going to split this line, which was of length 2, into length 1 here and length 1 here. Now we're able to find this height here from Pythagoras. This height here is simply going to be the 2 squared minus the 1 squared, which will give us the value of 3, and we've got to take the root of that, so that's going to be length root 3. So that's just a simple Pythagoras to get this length. So now we've got all the lengths and angles we need in order to work out the sine, the cosine and the tan for both 30 degrees and 60 degrees. Now you don't need to memorise this whole thing. What you want to do is just really memorise this triangle in length 2, 2 and 2, and everything else is easily to derive from it. So you can easily derive these angles and this length and these two lengths of 1 and 1. So let's go ahead and we'll do the 30 degrees and the 60 degrees. So we're interested in the sine of 30 degrees. So we come along here and we're interested in the sine of 30, that's the 30 degree angle there. The sine is going to be the opposite over the hypotenuse, so the opposite is 1 and the hypotenuse is 2, so that's simply going to be a value of 1 upon 2. Now we do the same thing for the 60 degrees. We're interested in the sine of 60 degrees. Now the opposite is going to be a length of root 3 and hypotenuse is going to be a value of 2. So that's going to be root 3 upon 2. So now let's look at the cosine of the 30 degrees. So there's the 30 degrees here. The cosine is going to be the adjacent over the hypotenuse. So the adjacent here is going to be root 3 and hypotenuse is 2, so it's going to be root 3 upon 2. So we have root 3 upon 2. So let's look at the cosine of 60 degrees. So here's your 60 degrees here, and your cosine is going to be the adjacent over the hypotenuse. So the adjacent is 1, the hypotenuse is 2, so that's going to be 1 upon 2. So finally let's look at the tan function. So looking at the tan of 30 degrees, well that's 30 degrees here, and the tan of the function is going to be the opposite over the adjacent. So the opposite is going to be 1, the adjacent is going to be root 3, so it's 1 upon root 3. And for 60 degrees, well there's 60 degrees here. The tan of 60 degrees is going to be the opposite, so that's the opposite here, root 3, and the adjacent is 1, so it's going to be root 3 upon 1, which is root 3. Now if we're interested in the angle 0 degrees and 90 degrees, we want to get these from our functions, from our curves. So we really want to be able to draw out the sine function, which is drawn here, the cosine function, which is drawn here, and the tan function, which is drawn here. So you really want to be able to commit these to memory and be able to draw them out and know where each of the angles are. So this is 0 degrees, that's 90, and that's 360. That's 0, 90, 270, 360. that's going to be 0, that's 90, 180, 270 and 360. So from these here we can see that the sine of 0 degrees is going to be, well, at 0 the height is going to be a value of 0. The sine of 90 degrees, well, 90 is this point here, so that's going to be a height of 1. For the cosine of 0 degrees is going to be a value of 1. And the cosine of 90 degrees is that point there, which is a value of 0. For the tan function, the tan of 0 is going to be a height of 0. And the tan of 90, well, that's 90 here, and the value heads off to infinity, so it's really undefined, so we can just put a value infinity here. Now finally, we're interested in the 45 degrees. Now to get the 45 degrees, we use a different triangle. So again, it's a right angle triangle. The length this time is 1 by 1. So if it's 1 by 1, we know that this here must be 45 degrees. And this one here must be 45 degrees. And we can get this length here by using Pythagoras. So it's 1 squared plus 1 squared, and we root it. So that's going to be a value of root 2. So we can see here that the sine of 45 degrees, well, you can use either one of these. Here's 45 here. The sine is the opposite, which is 1 upon hypotenuse, which is root 2. So that's going to be 1 upon root 2. And again for the cosine of this 45 degrees is going to be the adjacent over the hypotenuse, which is 1 upon root 2. And finally, the tan of this angle 45 degrees is the opposite over the adjacent, which is 1 upon 1, which is a value of 1. So you can see that we can build up this entire table here of the sine, the cosine and the tan of common angles of 0, 30, 45, 60 and 90 degrees simply by remembering two triangles. We remember this triangle here, which is equilateral of length 2 by 2 by 2. And secondly, we remember this triangle here, which has got a length 1, and this length here is 1. And we can derive everything else from these two little triangles. And we can also get the 0 and we can get the 90 degrees if we know what the functions look like. So it's becoming familiar with what the sine, the cosine, the tan functions look like, and remembering a couple of triangles, and you can derive all of these values yourself.